internet is nowadays a fundamental part of everyday life. Whether for work, entertainment, or accessing basic services like digital administration or healthcare, people are online every moment. The success of smartphones and the intensive use of social networks and online services has shifted most of the traffic to mobile networks. The third and fourth generations of mobile networks, 3G and 4G, gradually deployed since the early 2000s, account today for more than 60% of the global mobile subscribers. The global average data traffic per smartphone is currently 3 gigabytes per month, while the most recent predictions estimate that it will quintuplicate by 2024, favored by the advent of 5G networks. In mobile network deployments, the density of base stations per area depends on the subscriber density and the physical environment that affects propagation. In dense urban areas, operators may opt for small cell architecture, deploying base stations every few hundred meters to increase the capacity per area and satisfy high subscriber densities. Small cell networks pose a new challenge called the backhaul bottleneck, resulting of the difficulty to have so many high-capacity backhaul links between the base stations and the core network. Point-to-multipoint distribution at millimeter waves, where the available bandwidth allows high-capacity links, is the solution to backhaul bottleneck. But a new generation of components and particularly high transmission power amplifiers are needed at those frequencies. The H2020 TWEETHER project has responded to this challenge by developing and demonstrating a novel point-to-multipoint wireless network in 92 to 95 GHz, designed for high-capacity backhaul of small cells and fixed access.
TWEETHER is an Horizon 2020 project funded by the European Commission. It includes 1 big companies, 5 SMEs and 4 universities. The idea of TWEETHER was to use the higher portion of the spectrum, the W band that at that time was still not exploited, in particular 92 to 95 gigahertz, with a completely new approach that allowed to overcome the huge attenuation that atmosphere still provides, and has so far limited all the attempt to transmit data at millimeter wave. In the frame of the project has been developed a number of components that cover all the frequency range that are the sub 6 GHz up to 94 GHz. In particular, there were the development for the traveling wave tube, the integrated circuit, the subassembling, the assembling, the antennas, and then in order to form a complete system that presently is the only one existing at world level to transmit in point-to-multipoint at W band. The system was then tested and presented at the workshop in Valencia on the 28th of September and showed the potentiality of point-to-multipoint at W band for the first time in the world.
The field trial of TWEETHER project took place in the campus of the Universitat Politécnica de Valencia in Spain. A point-to-multipoint wireless network in W-band was deployed between a transmission hub and 3 network terminal equipment. The transmission hub, equipped with a low-gain pyramidal horn antennas, provided a 45-degree sector of coverage over the university campus. The network terminals, installed on different buildings and different distance from the transmission hub, 300 to 500 meters and 1.1 kilometers, pointed with their high directivity lens antennas towards the transmission hub. The system allowed an up-convert to W-band, amplify and radiate a multiplex of signals that was synchronously deconverted and down-modulated at the other end of the link. A monitorization system allowed to register the main performance parameters during the field trial, notably bandwidth, received signal strength, signal-to-noise ratio, noise floor, and frame losses. The field trial has demonstrated for the first time worldwide a millimeter wave point-to-multipoint system built with European technology developed in the TWEETHER project.
The challenge was to produce the electronics, the components, the technology that in Europe was not existing to provide these new opportunities for progress in millimeter wave communications. The idea in TWEETHER was to change technologies and to bring in wireless field new technology so far used for niche application like space or satellite communication, the vacuum electronic vacuum tube, the TWT. The TWT is the only device that so far is able to provide enough power to enable the point to multipoint at W band. Substantially, we have an electron beam that consists of the electron traveling at high speed, confined in a cylindrical shape, in a structure where there is an electric field, and the electric field affects the speed of the electrons. Some electrons accelerated, some are decelerated, and form aggregation high density charge that are then retarded by the electric field. And this mass of charge, since have a physical mass, transform the deceleration, transform the kinetic energy in radio frequency energy, and this permits to have amplification not possible by the normal solid state circuit.
The first millimeter wave point-to-multipoint system tested in a real environment is the result of the efforts of TWEETHER Consortium to successfully achieve the project objectives of designing, realizing and testing a novel wireless network architecture for high-capacity backhaul and fixed access. TWEETHER is contributing to enhance Europeans' millimeter wave industry with state-of-the-art novel components, both vacuum electronics and solid-state electronics, for boosting wide adoption of W-band systems in the near future. Traveling wave tube, power amplifier and low noise amplifier, mixer, synthesizer, multiplier, filter antennas, the full range of devices and subsystems realized by TWEETHER Consortium are now available in Europe not only for wireless communications, but for any other millimeter wave application. The technology integrated in the TWEETHER prototypes will be further improved to achieve upgraded performances and cost-effective production, leading to a successful exploitation of the project's results. Europe at the forefront in millimeter wave communications.